Now that we have discussed about the two important theorems, remainder theorem and factor theorem, now comes the new concept of the algebraic identities. Every part of algebraic identity is useful in solving many mathematical problems. So let's see what are the possible algebraic identities. Algebraic identities are the formulae which are said to be universally true for any variable. The left hand side will universally be equal to the right hand side, however be the value of the variable belonging to set of real numbers. So let's see some of the algebraic identities. The most important identity, as discussed in the lower classes, is that when I expand x plus y whole square, it must be universally equal to x square plus y square plus 2xy. Identity number 1 is how we see that this is universally equal to this, and this is true for all x, y belonging to the real numbers. This holds true for any variable x and y belonging to the real numbers. Similarly, I have the other identity which says that when I have x minus y whole square, it can be universally identical to x square minus 2xy plus y square for all xy belonging to the real numbers. Similarly, a plus b whole cube, a cube plus 3a square b plus 3ab square plus y cube. This is true for all x and y belonging to real numbers. Next, x minus y whole cube, which is x cube minus 3x square y plus 3xy square minus y cube, which is true for all x and y belonging to R. Next, x square minus y square is said to be identically equal to x plus y into x minus y, is how I identify the identity using x square minus y square equals x plus y into x minus y. Next, x plus a times x plus b by introducing the two new real numbers a and b can also be expanded and to be identically equal to x square plus a plus b times x plus ab, is how we identify for the two real numbers. For a and b belonging to the real numbers. Similarly, we have many other algebraic identities like x cube plus y cube, which is said to be x plus y into x square minus xy plus y square, is also one of the identity which makes this equal to this. X cube minus y cube is x minus y into x square plus xy plus y square, is how so on and so forth we have many algebraic identities. What if I have three variables introduced, x, y, z whole square? Then this also can be identified to be an identity, algebraic identity, a square, x square plus y square plus z square, 2xy, 2yz, 2xz for all the real numbers x, y, z, is how I identify the identity x plus y plus z whole square. What if I have x plus y plus z whole cube? this also has its own property. A cube plus B cube plus C cube plus 3AB into A plus B plus C cut. Now let's see the continuation of the algebraic identities. The next algebraic identity identified is x cube plus y cube plus z cube minus 3x yz is said to be directly equal or universally identically equal to x plus y plus z times x square plus y square plus z square is how we identify this example problem. Let's see how we can continue in identifying the applications of algebraic identities in solving mathematical problems. Say for example, I have a problem which says factorize 8x cube 27y cube plus 64z cube minus 48 144 xyz is what is the given problem, and I would like to expand to factorize this given polynomial in 3 variables x, y and z. So let's see how we can factorize this polynomial which is in more than one variable x, y and z being the variables using the concept of the algebraic identities. Now the given problem, which is 8x cube plus 27y cube plus 64z cube minus 144 xyz, can clearly be written as 8x cube, which is 2x whole cube, plus 27y cube, which can be raised to 27 being 3 cube, 3 times 3 times 3 can be written as 3y whole cube, so that this becomes a number, the perfect cube of 3y. And similarly, I have 64, which can be written as 4 cube, and this can be written as 4z whole cube. So the given polynomial can be expressed as 2x whole cube plus 3y whole cube plus 4z whole cube minus 144, which can be split as 3 times 2x times 3y times 4z. I can split this 144 xyz as 3 times 2x, which is the first term of inside the cube of the first term, and then 3y, which is inside the cube of the second term, and 4z, which is inside the cube of the third term. And then the reason why I expand and put it into this form is with the algebraic identity which is identified here. We know that the algebraic identity x cube plus y cube plus z cube minus 3xyz is identically equal to x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus xz. So using this algebraic identity, I compare the left hand side of this identity with the given problem. Now clearly I see that in place of x I have 2x, in place of y I have 3y, in place of z I have 4z, so that this whole left hand side of the algebraic identity can be equally substituted for the right hand side of the algebraic identity, where my x, which is 2x, I have my this 2x with y with 3y, and my z with 4z, which comes in the first factor x plus y plus z, and then x squared, which is 2x whole square, and y square, which is in place of y 3y whole square, and my z, which is 4z whole square, minus xy, your x being 2x and my y being 3y and z being 3z are equally substituted for x, y, z in the main algebraic identity. So 2x 3y minus 3y 4z minus 2x 4z is what we get when we expand through the formula. This can be further simplified so that I get this to be the first factor being 2x plus 3y plus 4z, and my second factor being 2x whole square, which is 4x square, and 3y whole square, which is 9y square, and my 4z whole square, which is 16z square, minus 2 times of 3, which is 6. Therefore, I get this to be minus 6xy minus 4 3 is 12. So I get this to be 12yz, and 2 times 4, which is 8. Therefore, I get minus 8xz is what I get as the factors for the given polynomial. Factorization of the polynomials which have more than one variable is done using the algebraic identities. This algebraic identity helps in factorizing this given problem. Applications of algebraic identities is to factorize the polynomials. Now let's see the other types of applications of the algebraic identities in solving many mathematical problems. As we have seen with the previous case of one of the algebraic identity which helps us in factorizing, the algebraic identities also help us in solving many problems which involve multiplication of two numbers. So let's see one of the application. The applications of algebraic identities is the topic for today's session. So for example, I have a question which says, find the product of 104 times 96. Then we can do this by using the calculator or with general multiplication, but without using the simple multiplication process. Also, we can just multiply the two numbers using the algebraic identities. Interesting, but yes, it can. Let's see how. Let's take the given product which needs to be simplified. I have this to be 104 times 96, which I need to multiply. So in order to do this, what I do is I try to express this in one of the algebraic identity form so that I can use it as a formula, and then the simplification becomes easier. So in this, generally what we do in these kind of problems is that we try to express through the standard numbers. 104 I can express in standard form as 100 plus 4, so that this 100 is easy to multiply or even to divide or add with other number. So the standard base here being 100 is taken for 104, so that 104 is written as 100 plus 4. This stands as the standard fixed number taken out here. Similarly, 96, if I express through the standard form, I can write it as 100 minus 4. So 96 can be written as 4 units short or 4 numbers short of 100, and 104 is 4 numbers ahead of 100, and therefore 104 is 100 plus 4 and 96 is 100 minus 4. The reason behind writing in this form is that we strike seeing this in the form x plus y times x minus y. We all know that x plus y times x minus y is identically equal to x square minus y square, or a plus b times a minus b is a square minus b square. Therefore, I get this to be a plus b times a minus b. Using this formula, I get this simply 100 square minus 4 square is what is obtained through the algebraic identity x plus y times x minus y is identically equal to x squared minus y squared. And this comes out to be 100 squared is 10,000 minus 16. So I get this to be 100 squared, which is 10,000 minus 16, which 9984 is the answer. Therefore, I get the answer to be 9,984. Therefore, 104 times 96 is 9984. This is very interesting because without using the general multiplication process, I can find the product of two big numbers using algebraic identities. This being one of the example case. Now let's see if this value as obtained through the multiplication of two numbers using the algebraic identity is verified to be true. Let's do the verification process by using the general multiplication of two numbers. As clearly we see here, I see that 104, when I multiply with 96, I get this to be 6 times of 4, which is 24, and 6, which is 2. 6 ones, 6. Next, 9 fours, 36, 9, 3, and 9, which when added gives me 4, 8, 9, and 9. And this comes out to be 9984, and this comes out to be 9984. Therefore, verification is true, is what I make the learning outcome. The learning of the product of two numbers using algebraic identity is very much true as compared to the general multiplication. Applications of algebraic identities in real life. Say for example, I have another set of an example which says simplify the value 99 whole cube. How do I simplify this without generally multiplying the numbers 99 times 99 times 99? Of course, we can simplify this using the algebraic identities. Let's see how we can use algebraic identities to solve this particular cube number. Now, as we see the question, I would like to simplify this 99 cube. Then clearly I write this to be 100 minus 1 whole cube, as discussed in the previous example, that we take the standard number as the base. So here the fixed standard number is 100, which is taken to convert the given number 99 in terms of 100. Therefore, the 99 cube can easily be written as 99 for 100 minus 1 whole cube. Now, once this is converted into 100 minus 1 whole cube, we see that immediately it gets compared with the identity x minus y whole cube. What is x minus y whole cube? It is an algebraic identity which expands to a cube minus 3a square b plus 3ab square minus y cube, or this can also be written as, this expansion is also equal to a cube minus b cube minus 3ab into a minus b. Both are the same expansions. Or this formula can also be written as x cube minus y cube minus 3xy times x minus y. Both mean the same identity for x minus y whole cube. So I'm going to use the second form of the identity for expanding x minus y whole cube, that is 100 minus 1 whole cube, indirectly 99 cube. So let's see how the expansion proceeds. So x, I treat 100 as x and I treat 1 as y, so that this gets reduced to x cube, which is 100 cube minus 1 cube minus 3x y into x minus y is what we get when we expand the given expansion. The 100 cube is 10 lakhs minus 1 cube is 1 minus 300 times 99 is what we get, which on further simplification gives us 1 lakh 10 lakhs minus 1 minus 9 3s 27 9 3s 27 29 of 0, which further simplifies to give minus 29701. Now we need to subtract these two numbers to get the value for 99 whole cube. As we know that the subtraction of 10 lakhs is what we get when we subtract this number from this. Therefore, my answer for 99 cube, which is multiplication of 99 3 times, is directly 970,299 is what we get as the value using the algebraic identity. Applications of algebraic identities in solving the problems, the math problems in real life.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.